So I'm continuing our Android talks. We've got Rebecca Franks up next. She's an Android Google developer expert with many years of experience in the mobile industry. She's currently working for a startup called Over, which is a brand building app for creating mobile designs such as Instagram stories, Facebook posts, etc. So she'll be talking about practical image processing on Android. So welcome, Rebecca.
Thank you, Lucy, for the introduction. Although, yeah, I kind of just said who I was in the start. Or maybe I didn't, actually. Did I introduce myself? No, I didn't. Okay, anyway, so today I'm going to be speaking about practical image processing in Android. Does this work? Yeah. So if you want to ask me any questions, you can find me on the internet at Rigaroo. I'll gladly help you with any sort of image processing related stuff that we can talk about. And I have a blog as well that you can go check out, and there's a lot of blog posts and stuff on there on Android Dev, so you can go read those as well. And like Lucy mentioned, I work for a startup called Over, and we've recently released a new version of our Android app onto the store. And this app allows you to basically add text onto graphics, is the whole concept of it. And with building this app, we started building it from the ground up. And there was, as you can imagine, you can put a lot of images into your project that you make. So you make a design, you add a couple of graphics, you create it, change colors, that kind of thing. So you can imagine that this kind of app has got a lot of challenges that you would have with it. So the first one that we ran across was that we needed to be able to process multiple images. So if you have a look at other apps such as like Instagram or something like that, it's normally just one image and you post it and that's the end of it. You don't have the ability to go back and edit that image or add additional things onto it. Like it's a once-off sort of fire and forget operation. We also had complex image processing that we needed to achieve. So we have an iOS app that's got a lot of all the stuff already built in, and we needed to mimic exactly what they were doing in their app on our app. Another thing that we had to do was we had to store these filters. So what I mean by store is that we had to persist it so that the user could later on load up that same project and adjust the value that they had changed before, which is a pretty complex thing when you look at the terms of image processing and what you can do with that. Because you can apply effects, but you might not know how that effect was applied if you're not the one in control of it. Another interesting part that we had was that we had custom canvas sizes. So we had the ability, or we have the ability to set the size of your export image that you're going to create. So you can create a very large image, a very different size image, that kind of thing. And this obviously caused quite a lot of problems as well. And like I mentioned, we had an iOS app that were really doing everything really, really well. So we had to make sure that this was working really well. Next. Okay, so I just want to talk a little bit about the mistakes we made and how we sort of overcome some of these. And hopefully this talk is what I kind of think of as the talk that I would have liked to have seen before we started going down into this image processing rabbit hole. So the first mistake that we made was that we were rendering our project's size instead of the actual display size. So you can imagine if a user adds a really large image, like a 8192 by 8192 image, we were trying to load that whole image up into memory, and obviously that wasn't very good for the phone. Another mistake that we made was that we were loading bitmaps synchronously. So whilst it didn't look too bad on like a really fast phone, like a Pixel 2 or Pixel 3, as soon as you put it on a slower device, it became very noticeable that we were doing something wrong with that. So that one was quite easy to solve. We just chucked it on a background thread. But the others were a little bit obviously more complex. The last problem that we had, or the mistake that we made, was that we looked at a lot of different image processing libraries and tools. And this, I think, took a lot of time, and this is basically what I'm going to go through today, the different ways in which you can process your images on Android. So let's take a little step back before we think about that, and let's talk a little bit about what a bitmap is exactly. So if you look at the actual data structure behind a bitmap, it's just a 2D array of pixels, okay? And what is a pixel? A pixel just contains 4 values, your alpha, red, green, and blue values as well. This is a really bad clicker. Okay, so how do you go up loading up a bitmap into your Android app? So if you Google this, if you're like, okay, how in Android do I make a bitmap show up in my app, you'll probably find the answer to use a bitmap factory. There's also another option called Glide, which I hope a lot of people are using. There's also Picasso, Fresco, and there's a whole bunch more as well. Like, you can search anything, you'll find a whole bunch of libraries. My recommendation is to go with Glide. So if we have a look at just go back to how we use a bitmap factory to load up an image, we will get across this. You've probably run across this code if you've looked at the documentation online. So it's quite a large chunk of code just to load up an image. And a lot of the time, you don't really care about a lot of the certain things. You're just like, there is an image, I need to display it on the screen. Like, why can't you do this? So with Bitmap Factory, it becomes a lot more difficult because not only do you have to download the bitmap yourself first, but you also need to start caching and doing all your cache management yourself. So storing the file, making sure that you don't load up the file again and again. So that is not included in this code snippet that we have here. So it's basically like the very hard way to load up a bitmap in Android. So if we have a look at Glide, so Glide makes this super easy. You just pass it a context, and you pass it a URL, so you can just be like, here's this image on the internet. Please download it and put it in this image view, okay? And this takes care of a lot of the different complexities for you. So it takes care of caching, which is super important if you want to save your users' data. It takes care of loading up the size, the correct size for display on the device, which the other one you had to calculate that all yourself and all that, which is really, really a pain. As well as it takes care of downloading the image for you. So you don't have to write like a async task or a coroutine or something like that to go and fetch the image and then put it somewhere. So Glide, definitely one for the quick wins. So I just want to have a question here. How many of you have run into an out-of-memory exception? Were you using a bitmap when you did that? Images? Yes, you were loading up images. Okay, cool. So I'm sure this is not a foreign concept. And basically, you need to be able to work with this error and not be afraid of what it means or how it works. But a lot of the time, it can occur for different reasons, right? So one of the big reasons is you're just loading up a bitmap that's too big. Okay, you're loading up a really large bitmap, and the device just cannot handle that, and it just crashes. It's like there's no more memory. It can happen for other reasons, like memory leaks or stuff like that, if you rotate and you're not freeing up resources, but we're not going to get into that today. Anyone run into this exception? Bitmap too large? A few people. Okay, cool. So this one is basically you're taking a bitmap that's huge that you've managed to load up in your memory, which is amazing in itself, and then you've tried to draw it on a canvas that's and there's a limit on your canvas, right? So your canvas is like, nope, we cannot draw this, just a crash. So that one is a bit more of a unique one, I guess. Okay, so the first bit of advice that I have is that you need to scale your images. So don't worry too much about what that image is, it's just for looks. But basically, I want to explain why you need to do this. So if you think about it, if you take an image that has got that height of 1920 and a width of 700 pixels, you'll be using, if you load up that exact size into memory, you'll be using 5.3 megs of memory when you load up that image. Now, that might be okay for 1 or 2 images, but as soon as you start to add more and more images, it becomes really, really slow, and your app might just crash with out of memory. So the point of this is that you should scale it down to the size of the view that is being visible on screen. So when you display any kind of view on Android, your image views and that kind of thing, they're really actually small and don't take up that size pixel. You don't need to load up a very large image like that. So if you see we scale this one down, we'll be saving a lot of memory on the device and therefore potentially avoid an out of memory or delay it at least until later. Okay, so how do you scale down your image? So if you Google this and go to the bitmap factory, back to those options, there is a whole long blog post about how to do this. And it's quite complex, but it's all online there, so I'm not going to go through too much of it. But basically, you can provide in the height and width and provide that sample size, and then Android will load up that image at that size. Or if you use Glide, you can just say something like this. So if you use Glide, wait, if I go back to this one, if you use Glide already, it's doing it for you, okay? So Glide will automatically take that image view as dimensions, so the measured width and measured height, and it will load up that file at that size. If you need the bitmap itself, so the actual bitmap file, you can use a Glide extension to say .as bitmap, and then give it the width and the height that you want it at, okay? So if you provide a really large width and height, Glide is probably going to be like, nope, you're still out of memory. There's no magic that it magically unlocks more memory for you. So Glide, much easier to do this as well, or much nicer API. Okay, so we've talked a little bit about how we load up bitmaps and why we need to scale things down. So I guess let's get to the fun part of actually applying cool image effects. So in our app, we have some really cool looking image effects. So like we can adjust the warmth of an image, you can adjust the fade, saturation, that kind of thing. And there's many different ways in which you could do this. So the first way is to use a getPixel and the setPixel method. I'll go more into detail about that. The next way is to use Glide image transformations or GPU image. Another way is to use a color matrix. Another way is to use RenderScript. Another way is to use OpenGL. Or you could also just use native C++ code. So you can imagine that there's like quite a lot of options. Like, how do I know which one to pick? And there's more, probably. Okay, so today we're not going to go through OpenGL or native C++ code because luckily we got to the RenderScript part and we were like, yay, most of it works with RenderScript. So we won't be going through OpenGL and native C++. So what is getPixel and setPixel? So in Java and in Kotlin, this is Kotlin code, but on this you have, on a bitmap object, you get the methods setPixel and getPixel. So you can go and literally write a for loop and say, okay, for every pixel in this bitmap, change the color or apply some kind of effect. So in this case, I'm applying the color blue, so it's just going to output a whole blue bitmap because why not? But the problem with this is that you're running this on the CPU, okay? So if you have a really large image, this is just going to slow your app down to an absolute crawl. If you don't mind it processing in the background, maybe this is the right option for you. So one of the big pros of it is that it's super easy to understand, right? We all know how to use methods in Kotlin and Java. We just say getPixel, setPixel. I can do some things with that. Also, a nice pro about it is that you're controlling the exact pixel value. So like I mentioned, this was important for us because we needed to be able to load up those filters again. So we needed to know exactly how those filters were applied and what percentage of the filter was applied. Another con that I mentioned already is that it's super slow. So it's running on your CPU and not the GPU, which is your graphics processing unit. And your GPU allows you to do things in parallel. Okay, so you can say, hey, GPU, here's a whole bunch of operations, execute them in parallel. And then your GPU does it within a few seconds. Whereas the CPU is like, okay, one by one, we'll go through all these pixels, and it takes a lot of time. CPU execution, I'm getting ahead of myself. No parallel execution, yeah, so it's not parallel at all, it's all running one after the other. Okay, so let's talk a little bit about color filters. So what is a color matrix filter? So a color matrix filter basically takes the color of each pixel that you have and it draws it with a new certain paint that you provide it, okay? And if we have a look, this is like the basic formula for it. So a color matrix color filter, you create a 4x5 matrix, and you can see we've got like the number or the letters A to T here, so those are the values that you would set. And that 4x5 matrix is then applied to every pixel that you are going to render on screen for a bitmap. So how exactly does it work? Anyone remember matrix multiplication? Kind of, okay. Well, anyway, so it's very, it just basically calculates the RGB and alpha channels and then combines that for each pixel and gives you an output pixel value and you get a new image. Pretty magical. Yeah, and then your pixel value will just take that RGBA value out. So this is an example of what a color matrix could look like. So the matrix is the 4x5 part in the middle. And this is what we call the identity matrix. So this is basically going to give me the same image in as what the same image out as what I put in. So it doesn't apply any effect. So if we wanted to say, for instance, invert the colors of our image, how could we do that? So this piece of code basically just takes up a bitmap, loads up a bitmap into a canvas, creates a paint object, and on that paint object itself, we set the color filter that we want to use. And then we create this color matrix, so this is similar to the matrix that I've just shown you, and we've just now inverted the numbers. So we said -1, and that kind of thing. And then we can just draw the bitmap. Okay, so we can say canvas.draw the bitmap with with this color matrix in the paint with this bitmap. So this is the output of inverting the image. You can see the effect of it. And I didn't explain to you how fast this is, which is missing from my slides. But basically, this happens super quickly, okay? So your color matrix color filters are running on the GPU, and they are very quick to execute and happen. So what else can you do with color matrix color filters? So you can do some cool things, like you can adjust the warmth of an image, you can adjust the exposure, you can adjust saturation, contrast, grayscale, and sepia. And there's a whole bunch more of color filters that you can use. So there's a lighting color filter and a Porter-Duff color filter that you can apply as well. And if you want to read more information about this, I'm not going to go through all of them, because there's a lot. There's a really great blog post by my colleague who's sitting in the audience, Nick, about manipulating images and drawables with Android's color filters. So it'll go through all the different examples and how you can apply them. Okay, so let's talk a little bit about the pros of this method versus the cons. So the pro is that it's easy-ish to understand. I mean, I wouldn't say it's as easy as the set pixel, get pixel, but as long as you kind of understand matrix multiplication, you're good. It's super fast, runs on the GPU, so you don't have to worry about it slowing down your app. And you can write it in Kotlin or Java if you want, so you don't have to interface with any other language or anything like that. The best part about this is that you also understand the exact filter that's being applied. Because you're setting the values of the matrix, you can store that and retrieve it at some point and load it up again. So it's really, really nice for restoring your state of your image. A big con, though, with this is that it can't do all effects like sharpen or unsharp mask or anything that requires looking beyond the current pixel. So if you have a filter like unsharp that requires looking at the surrounding pixels, you can't use color filters. And that's it for that. The next interesting one is the image filter view. Anyone heard of this? No? Okay, great. So image filter view is an interesting one. This one was introduced in Constraint Layout 2.0, which is a bit of a weird package to package it in, but it's there, and it's actually really, really cool. But basically, the image filter view contains 4 methods that you can use. So you can set a contrast, a crossfade, a saturation, and a warmth. And that happens for you automatically. If you have a look here, this is just me defining an image filter view in XML. And you can set the contrast, saturation, and warmth here in XML. And this will go and actually just use color filters under the hood. And it will go and run it on the GPU, and it will be super fast. So here is an example of the image filter view working. You can see it's pretty fast to execute and apply different effects onto an image. Okay, so what are some of the pros of using this way? So this is also super, super easy to understand. You don't have to even understand matrix multiplication. You can just be like, set this to this value and we'll be good. It's fast because it's just using color filters. And it's a super nice API. Like, if I just have to set one value, I don't have to know what I'm doing. That's really great for me. You can use Java or Kotlin. But the big con is that it also can't do everything, like I mentioned. So it's got the same limitations as a color filter because it is just using color filters on top. And another con that was a bit of a con for us is that the values that you're passing into there are kind of abstracted away from you. So you don't really know what the values are that are going to be applied, and perhaps at some point that API or that SDK could change how it works, and then your images just don't work as what they were working like before. Okay, cool. So let's talk a little bit about Glide and what you can do with Glide image processing. So there is a great library online called Glide Transformations by Wasabi. I don't know how to say that. But basically, with Glide, you can just say, load the image and apply this certain effect. So I can apply a blur, I can apply, there's a whole bunch, like grayscale, that kind of thing. So this is really, really great and super easy to use. So let's talk about some of the pros of that. Easy to understand, It's super fast as well, because they're doing their own optimizations under the hood. Not really sure what that is. I mean, you can read the code and that kind of thing. A lot of it is using Renderscript, which we'll get into, and a lot of it is also using color filters. It's a nice API, right? So you just say, apply this blur onto this image and be done. We're happy. You can use Java or Kotlin, super nice. But another con is that you can't do everything unless the library has it, or unless you make a pull request and submit that yourself. Make a new filter. Another big con for us was that values were abstracted away from us. So this library is a third party. We were just providing it some values, and we were like, OK, we don't really know how you got to that blur effect or how you applied that effect. Looks good, but can we persist this value and restore it later without worry that the library would change? And then, obviously, because of the same thing, we would be then dependent on this third party's implementation of how they made image processing work. And if they change that, older projects might load up and look really weird. OK, so let's talk a little bit about Renderscript. Has anyone here used Renderscript before? One person, which is my colleague. OK, cool. We're alone here, Nick. OK, cool. So what is Renderscript itself? So Renderscript is a framework on Android for computationally expensive tasks. So anything that will take a lot of time to process is something that you might want to use Renderscript for. So it parallelizes your tasks on the CPU and the GPU. So if you have a device that's super slow or something like that, it might use both the CPU and the GPU to process things. And the language of Renderscript, this is the hard part, is not Kotlin, unfortunately, but it's a C99 derived language, and it's basically used for writing really high-performance compute code. OK, so I just want to take a little bit of time to differentiate between two different parts of Renderscript. So you get a Renderscript compute, and you get Renderscript graphics. So the Renderscript graphics has been deprecated. OK, so we won't be talking about that in this session. But the Renderscript compute module is still widely used for image processing, which sounds weird because graphics might be image processing, but graphics is like 3D rendering and that kind of thing in this case. OK, so we'll be talking about computes, and hopefully they don't deprecate it. OK, so how do you actually make a Renderscript? How do I use it? So basically, in your Android folders, you would create a RS folder for Renderscript, and inside there you would create the files for the filters or something that you want to do with Renderscript. So in this case, I have a black and white filter, and I have an exposure filter. So this is where you need to prepare your minds for the non-Kotlin code. But basically here, this is a very simple version of what you can do with Renderscript. And the first 3 lines here is just setting you up for working with Renderscript. So we're setting the package name, we're setting the version number to 1, which hasn't changed, so it's always the same. And then the rsfp_full is basically setting the mode of Renderscript. So is it going to run in a relaxed mode or in a full mode? And that just means how quick and how accurate you want it to be. So if you say full, it's going to be more accurate because it doesn't, it executes with the proper, it executes using a more precise float values and that kind of thing. OK. So how do we use it? So I have a method called setBrightness. I should have called it setBrightness, not setBright. But basically, this takes in a value, and we're going to call this function from our Kotlin code. So we've got a static float that we're storing this brightness value in, and we're just going to set the brightness before we run the filter. The next method that I've got is the exposure method. Okay? So this is actually going to take in the image, process it, and produce an image out. Okay? But it looks pretty interesting, this method, because it doesn't have a bitmap object or anything like that. It takes in one pixel and produces 1 pixel out. Okay? So this is the method that will run for every single pixel on your bitmap. Okay? So in this case, I'm just clamping the value of the whole of the computation, clamping it between 0 and 255, which is the max value that you can have for a pixel rendering value. And we're timesing the in R color, the in green color, and the in blue color, timesing it by the brightness that we have, and then we're setting the output pixel to those values. So this method is basically the whole juicy part of like Renderscript, because this will run for every single pixel in parallel. So how do we use this in Kotlin or Java? So basically you want to create a new class or put it somewhere, and you create this Renderscript variable. And you do that by saying renderscript.create, and you provide a context into it. The next thing that you need to do is load up or create the script object. So with Android Studio, it'll automatically generate the script C underscore exposure class, because we've created that exposure.rs file. So this will automatically be created for us. And that we pass in the Renderscript context into it. So how do we actually run the filter? So in this example, I've got the bitmap that I'm putting in and the exposure value that I want. So I'm creating an output bitmap. And then we have to create these things called allocations. Okay? So this is basically just allocating memory on the heap for you to use and interact with. Okay? So we create a in allocation and an out allocation. And we'll be using these two from our bitmaps. And then to actually run the script, we would say script.invoke underscore set brightness. So you're like invoking a method in the script, and we're setting the value of the exposure that we have. And then it also generates these for each methods that we have. So this for each is basically just the loop that'll run across the whole bitmap that we have. So we pass in the temp in, which is the allocation for the input bitmap. And then we pass in the temp out, which is also the allocation for the output bitmap. And once we've done that, once we've run it, we can copy the output values to a bitmap, because there's a copy to function on the allocation. And then we want to do some cleanup methods like destroying all of that and just making everything, making sure it's cleaned up. And then we just return that new bitmap to the function that requires it. And the last thing that we need to do with Renderscript is you just need to destroy the context or the Renderscript context that you make and the script that you have, just so it frees up some memory as well. Okay, whew, everyone all right? Okay, so this is an example of how it's running. You can see the exposure is adjusting in this example. So you'll also notice in this example that there's like a little bit of a jitter. Don't know if that's just me, but I've got a really good eye for seeing when things aren't working very properly. But basically, in this example, there is another example online that you can have a look at that swaps between two bitmaps, which is another thing that a lot of image processing apps do. So they process one, and in the background they process another, and then they like ping pong, they call it, between the two, just so that the effect of you like scrolling between doesn't look as jarring, and your eye sort of sees like, okay, this is working a lot less janky. Okay. And beach balls, great, okay. Okay, so let's talk a little bit about convolution matrices. Anyone used those before? Okay, cool, a few people. So basically, if we have a look at the effect of like sharpening an image, what we would need to do with sharpening, basically what it does is it doesn't look at the current pixel itself. It looks at the current pixel with all the surrounding pixels as well. So it says, okay, this pixel is this certain value, but this value isn't like that, and then it adjusts the filter based on that, and that's how you get the sharp lines or like edges of your thing. So for that kind of thing, you need to use convolution matrices. Okay? So if we have a look at this, we have a sharpen kernel, and that's just a matrix of 3 by 3, and that is like the standard sharpen kernel that you get. And if we have a look at like an example of a pixel in our whole image, we're looking at this middle value of 40. So if we apply this sharpen kernel to our pixel value within our image, we get a resulting pixel value for that new pixel that we've worked with. But we had to work with surrounding pixels in order to get that new value. So this is also just doing matrix multiplication to get that. Okay, so how do we do this with Renderscript? So it's very similar. We create the Renderscript context, but the difference is that in this case, we're creating a script intrinsic convolve 3 by 3 matrix, okay? So we didn't have to create a Renderscript file for this. We don't even have to write Renderscript code for these kind of matrices. We can just create these new objects and provide in a matrix, and then it will process the image with that new matrix. So if we have a look at the actual apply filter method that we have, I'm creating a sharpened matrix, which has got the multipliers based on your scrolling of your seek bar. And then we call this method called apply filter convolve, which I'll get into now. So, oh, nice animations. Okay, so how does the apply filter convolve work? Basically, in this, we're taking in the bitmap that we want to work on and the coefficients of the matrix that we want to apply. So very similar to the previous example, we create our allocations, we create our input and output allocations and our bitmap out. And then with this convolution script that we have, we set the input, so that matrix of new values that we want to apply. We set the coefficients as well, and then we run a for each on that allocation, okay? And then at the end of that, that just runs your script. We didn't have to write any render script in this case. We just had to interact with the API to get there. We copy our output to our bitmap, and we then just destroy everything and clean up and return the new bitmap that we've created. And don't forget to clean up your render script as well. Okay, so this is showing a sharpen effect. I'm not sure how good this projector is rendering it, but basically, if it was rendering it really nicely, you'd be able to see this image sharpening and unsharpening. Don't know if that's a word. Cool. So there's a bunch of built-in RenderScript functions. So there's a script intrinsic blur, so you don't have to implement blur yourself. You can just use this one from RenderScript and provide it with values and then get it out. There's a script intrinsic LUT, they call it, or lookup table. And that's really cool because the lookup table basically gives you a bitmap that maps values to certain values. So if you have a filter that you want to share across different programs, like if you have an iOS app and an Android app, you can all use this lookup table to make sure that you apply the same filter because it just looks up a certain pixel value and produces a certain pixel value out. And there's a bunch more that you can go and have a look at within RenderScript that you can use. So there's a whole bunch of further examples that are great for you to go have a look at. So this efficient image processing talk from Nicholas Raud was a really good talk. He spoke about how you can create a caching pipeline for your image filter effects. And there's just a whole bunch of really good content in there. And there's also some stuff on RenderScript there as well. It's quite an old video, but it's still all valid points that he has. And then there's a nice example, the basic RenderScript example. And this is from the Android team. And this just shows you that ping-pong effect that I was talking about and applying just one basic RenderScript filter to a certain image. And then the AOSP source code has got the Gallery 2, which is the new, one of the galleries that were implemented on the actual Android phones. And inside this is like gold. There are so many cool filters inside there in RenderScript that you can just have a look at and copy because it's open source and free to use. Okay, so what are some of the pros and the cons of these? So the pro of RenderScript is that it's super fast. It's running on the GPU. We don't have to worry about it slowing us down. It's super customizable because we're literally affecting all the pixels ourselves. We can customize it and make it however we want, make it work however we want. And then we have parallel execution on the GPU, so because it's also fast because of that. And I would say the interactions between the layers aren't super complex. Like you have to create that object, but a lot of it is created for you. I think the big con about using RenderScript is that it's like a whole new language, right? So when you read those source code files, you're like, this is not anything I understand. But after a while of playing with it and seeing like a lot of examples, it's not too bad to work with. Another big con is that you have to manage your memory. So you have to know exactly, like I need to destroy it at this point or load it up and allocate the memory. Another con is that it's also using a native library. So it adds a little bit of extra size into your app that you produce. You can use just the built-in one that doesn't add extra SO file into your APK, but other than that, it's a little bit extra download size. Okay, so what should you use as an Android developer? How do you choose between, what was it, like 5 different types that I just went through? It's all a whole bunch of different things that you can look at. So if you don't really know what you're doing and you're just like, I need a filter and I don't really care about loading it up again or working with it again, just like filter my image and put it on the internet. I would go with something like image filter view or looking at your glide transformations, because those are super easy to use and quick and effective. If you want to get a bit more like a fine-grained approach to like exactly knowing the pixel operations that you're doing on your image, then I would recommend looking at something like your color filters, Renderscript, or possibly even OpenGL, if you get that far. But that's how I would choose between the two. Okay, so some final tips for you if you're going to be working with images on Android. The first one is that you're going to run into an out-of-memory exception at some point. So be comfortable with it and make sure you know the things that you can do in order to fix it or make it less likely. Another tip is that scale is to display. So this one was like quite a really good saving for us. Once we had implemented this, the memory usage of our app like really dropped quite a lot, and it was a lot more snappy experience that we could have on the device. And then the last tip that I have is that you should use whatever is easiest for you. So if you have a team of people that don't know Renderscript and don't have the time, or like it just doesn't make sense for you, then don't use it, just because it's like the most customizable or something like that. Okay, so that's all I have for you today. I hope that you learned something about image processing, and I hope to see some cool photo effect apps coming out of South Africa. Thank you.